Hey guys, I just wanted to make a quick video for you explaining a concept that I get a lot of questions about, and that deals with the unit circle and also the inverse trig unit circle. So most of you guys are probably pretty familiar with the unit circle, and I have my tangent values on here as well. You guys know that when you do like sine of pi over 6, that you're looking at the y coordinate, and the sine over pi over 6 is equal to 1/2. All right, or if we did like cosine of 2 pi over 3, we would go to the x coordinate, and we would say that that's equal to negative 1/2, and so on. And the tangent values are on the outside. So if I said like, what is the tangent of 7 pi over 4? The idea is we go to 7 pi over 4, the tangent is this outside value, and tangent's equal to sine over cosine, so that's equal to negative 1. So a lot of people usually feel pretty familiar with that process. It's the opposite process that I know causes a lot of difficulty. So I just want to go over the opposite process now. I call this the inverse trig unit circle. And you'll notice on the inverse trig unit circle, there's a few major differences. The first is that there is no third quadrant whatsoever. The third quadrant is out of here, right? The second is that on the fourth quadrant, instead of the normal angles, I've got negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. And the reason for that is the graphs of inverse sine, inverse cosine, inverse tangent. It has everything to do with their domains. So if we consider the graph of inverse sine x, it goes something like this, right? It only goes to negative pi over 2 and positive pi over 2, okay? So if you do inverse sine of something, it only gives you an angle between those two values. So that's why that fourth quadrant is negative pi over 2. When we do inverse cosine, it is a graph that looks like this. So it goes up to pi, and that's what that first and that second quadrant are for, because it goes from 0 to pi. Inverse tangent, right, is a graph that looks like this, and it gets closer and closer to pi over 2 and negative pi over 2. So when you do inverse sine, inverse tangent, it'll give you an angle between negative pi over 2 and positive pi over 2, first in the fourth quadrant. Inverse cosine is 0 to pi, which is first in the second quadrant. So when we go back to this now, if I say something, I know for a normal unit circle, we write all students take calculus, ASTC, indicating the signs. For the inverse trig unit circle, I would write inverse sine, right? Inverse tangent, and then inverse cosine, okay? As an idea of what the angles or the quadrants that those are defined in. So when I say something like inverse sine of negative 1/2, I'm allowed to look in the first and the fourth quadrant, and I'm looking where does the sine equal negative 1/2? It's right here, so I would write negative pi over 6. And that would be the value your calculator would give you if you did that as well, obviously in radians. If you were in degrees, it would say negative 30. Or if I say inverse cosine of negative square root of 3 over 2, right? Inverse cosine is in the first and the second quadrant, so I'm looking where does it equal negative square root of 3 over 2, and that is at 5 pi over 6. So never will you do inverse cosine of something and it'll give you an angle in the third or the fourth quadrant. Same thing, never will you do inverse sine of something and it'll give you an angle in the second or the third quadrant. And if it was in the fourth quadrant, it would give it a negative value of that. So when we see something like inverse tan of negative 1, however, it is true that the tangent equals negative 1 up in this quadrant. Inverse tangent is not defined in that quadrant, so we would say that that is equal to negative pi over 4, all right? Because we were looking at the inverse tan value down here, and we're only allowed to look in those two quadrants. So hopefully that helps. Definitely practice that skill, and let me know if you have any questions.